All right, guys. So today we're going to learn some new formulas called the sum and difference formulas. All right. So as it says here, we'll use those to evaluate trigonometric functions, verify trigonometric identities, and solve trigonometric equations. All right. So essentially, we're going to be doing all the same stuff that we've been doing so far in this unit. We're just going to throw in some new formulas. All right. So here are the sum and difference formulas for sine. All right, so if we have sine of u plus v, all right, that is equal to sine of u times cosine of v plus cosine of u sine of v. All right, the difference formulas are very similar. Sine of u minus v is equal to sine of u cosine v minus cosine of u sine of v. All right, guys, here's the sum and difference formulas for cosine. All right, do be mindful here. A lot of people mess these up because when you have cosine of u plus v, there's actually a minus in the formula. And when you have cosine of u minus v, there's actually a plus in the formula. So do keep that in mind. All right, so cosine of u plus v is equal to cosine u cosine v minus sine u sine v. And cosine of u minus v is equal to cosine u cosine v plus sine u sine v. Yes, sir.
With the factors that are multiplied, the order doesn't matter, right? You just put cosine v times sine cosine u.
Yeah, that's correct. Yeah, multiplication doesn't matter. Order doesn't matter, of course. Yeah.
You actually want to get it.
He's a guy. Greece is not like required watching for a male.
Have you watched Greece?
Yeah.
Okay. I agree with Greece.
I've seen a little bit of it, but I haven't like sat down and watched it. I haven't watched it.
All right, guys. Last but not least here, all right, are sum and difference formulas for tangent. All right, so tangent of u plus v is equal to tangent of u plus tangent of v divided by 1 minus tangent of u times tangent of v. And tangent of u minus v is equal to tangent of u minus tangent of v over 1 plus tangent of u times tangent of v. Well, it's all done if you ever take a proving mathematical theory course. You will find out how. And it's not really very interesting, to be quite honest with you.
You don't think recommend it?
No, the only way you really have to take proving mathematical theory is if you're a math major.
So did you take that?
Yeah, oh yeah. I take that back. They make you take it if you're a computer programmer too.
Computer programming. Proving mathematical theory.
Well, because in proving mathematical theory, the kind of logic you have to take logic, which is how you prove like the steps that you use to prove math. And all computer programming is based off mathematical logic. I mean, that's kind of how it is. So, like that's I started off college as a computer science major, and that's when I actually took proving mathematical theory. But then I switched to just straight mathematics. All right. So, find the exact value of each expression. All right. So, and this is just kind of to prove a point. Okay. So that's kind of the point that I'm going to prove right here. All right. So you can think of this as sine of u plus v. All right. So our formula for sine of u plus v is sine of u cosine v plus cosine u sine v. All right. So if u is pi over 4 and v is pi over 3, all right, then this becomes sine of pi over 4 times cosine of pi over 3 plus cosine of pi over 4 times sine of pi over 3. All right, so of course we can get all of these values from the unit circle, right? So sine of pi over 4 is simply square root of 2 over 2. Cosine of pi over 3 is 1/2. Plus cosine of pi over 4 is also square root of 2 over 2. And sine of pi over 3 is square root of 3 over 2. All right, so of course when we multiply fractions, we multiply across the top, multiply across the bottom. So this will then become the square root of 2 over 4 plus the square root of 6 over 4. And since these have a common denominator, you can just say the square root of 2 plus the square root of 6 all over 4. All right, so this would be our final answer here. All right, let's see how that compares to just sine of pi over 4 plus sine of pi over 3. All right, well, sine of pi over 4 is simply square root of 2 over 2. And sine of pi over 3 is simply square root of 3 over 2. All right, so this would just equal, they have a common denominator also, square root of 2 plus the square root of 3 all over 2. Are these the same thing?
Yes.
They are? No. These are definitely not equal to each other. Okay? So that's kind of like a lot of students, especially those students who think that sine of theta is sine times theta, which I have said a bazillion times. No, 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 right? You cannot think of it like that. It is not multiplication. All right? Students that think of it as multiplication would just distribute this sign and then they try to do this and they're completely and utterly wrong every single time, right? So you have to, in order to correctly do this, you have to use this formula. You cannot just pretend like it's multiplication, like I've told you a bazillion times. You cannot, all right? you will be very incredibly wrong and essentially miss every point, right? You know how like I try to give you as many points as possible for doing some correct work. Um, if you do this for that, like if you're asked this and you do this, you get absolutely 0 points because you did absolutely nothing correct, right? So do be very mindful. Now, these formulas on the test, you're going to be given. I'm going to give them all to you, right? So you don't have to like worry about memorizing them, right? But you do have to know how to use them. Okay. So this is kind of another just showing you that these things are indeed very different, right? So again, this is u and this is v. So this is cosine of u minus v. So cosine of u minus v is cosine u cosine v plus sine u sine v, if I remembered that correctly. All right, so of course u is 135, v is 30. All right, so this is going to equal the cosine of 135 degrees times the cosine of 30 degrees plus the sine of 135 degrees times the sine of 30 degrees. So again, we can get all of these values from our unit circle. All right, so the cosine of 135 is negative square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. Sine of 135 is positive square root of 2 over 2. And sine of 30 is 1/2. So multiplying our fractions here, we're going to get negative square root of 6 over 4 plus square root of 2 over 4. So of course these have a common denominator, so this is negative square root of 6 plus the square root of 2 all over 4. All right, of course, if we are one of those terrible mathematicians that think that these things are equal, right? Cosine of 135, of course, is negative square root of 2 over 2 minus the cosine of 30 is square root of 3 over 2. So these have a common denominator. So this would be negative square root of 2 minus the square root of 3 all over 2. All right, which obviously, again, these things are not equal to each other. So please, 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 and no matter how many times I beg for students to not do this, every single semester and every single class, I have at least 2 to 5 students who just see this and automatically do this. And they miss everything and do terrible on this test. I have no idea. Basically, they just don't pay attention at all, ever, and don't listen to a word I say. Like that's when I grade those papers, I'm like, wow, they really did not pay attention to one single thing I said, right?
Does that take into consideration of how sympathetic you are grading them?
Oh, absolutely. Yeah, absolutely. Like students that you know do all their work, keep up on all their work, like ask questions when they don't understand something, like you do it subconsciously, but you tend to be more like sympathetic to their papers when you grade them and give them the benefit of the doubt. You know, if they didn't show some work that they probably should have shown, but you're like, I know they do all their work. I know they know how to do this. Like, still kind of give them credit for it. Yeah. Right. Exactly. Yeah. Okay. So, guys, the whole point of the sum and difference formulas are to help us do certain angles that are not on the unit circle, but still be able to find the exact value. All right, now guys, when they say exact value, right, that means what we were just doing, right? Like stuff with square roots and all that kind of stuff. Now, I love when students, especially like while we've been hybrid, or even last year when we were just on full quarantine, right? And like exact value, and they're supposed to show all this work, and it's blatantly like on the non-calculator portion of the test. So they obviously just write down, oh, that's 0.68732. First of all, no, that's not exact. All you did was round it, right? If you've ever rounded it, that's not an exact answer, right? And you didn't show any of the work, so it's just like, oh, that problem was worth 7 points minus 7. Like you don't even there's no like consideration. It doesn't matter, right? You obviously used a calculator because there's no way that your brain told you that that was 0.78223 just magically, right? So when it says exact value, please don't be one of those students who just randomly put some obvious calculator decimal down with zero work shown whatsoever. I will laugh at you. All right, but and I really do. Like when I'm grading papers, it's really funny. Like at home, like I'll just laugh, like literally laugh out loud. And like people at home will be like, that bad, huh? Yeah, yeah, this student is that bad. Right. So you guys know who you are. All right. So, anyway. All right. So before we could really only do exact values of things that were on the unit circle, right? Of angles that were on the unit circle. Is 75 degrees on my unit circle? No. All right. But it can be created via some sum or difference. All right. So do you agree that the sum of 75 is the same thing, that the sine of 75 is the same thing as the sine of 45 degrees plus 30 degrees? Yeah, right. 45 plus 30 is definitely 75. All right. So if we think of this as our u and this as our v, all right, then we can go ahead and use our formula. All right. So of course this is sine of u times cosine of v. And this is sine, so the sine is the same. So plus cosine of u times the sine of v. All right, so then of course we use our unit circle values. All right, so this is square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1/2. And you'll notice that, like, because we're using all of the same values, right? Like, there's only so many things that we can use to combine, and all of our unit circle values are kind of, repeat themselves a lot. That these will also repeat themselves a lot. It's just kind of which order are they in, right? Sometimes it'll be like in this case, it's the square root of 6 over 2 plus the square root of 2, over 4. Right, over the square root of plus the square root of 2 over 4. All right, so then of course we can combine this together, right? Square root of 6 plus the square root of 2 all over 4. And that's it. That's our final answer. All right, now like I said, these will all look very similar, right? You typically always have these same kind of values up here. It's just which one comes first, right? And is it positive or is it negative, right? You may have, and here we have the square root of 6 plus the square root of 2 over 4. For some other similar type problem, you may have the square root of 2 plus the square root of 6 over 4, or the square root of 6 minus the square root of 2 over 4. Right? So all these things will be similar. So don't think that just because you're getting all answers that kind of look the same that you're doing it incorrectly. Quite to the contrary. Okay, so go ahead and try this one. All right, so this one works very similar, of course. So we can think of cosine of 75 as cosine of 45 plus 30. And of course, it wouldn't matter if you switch these around, right? It's irrelevant. All right, so this would be, oh, what just happened there? Cosine of 45 times the cosine of 30 minus sine of 45 times the sine of 30. So here we would have square root of 2 over 2 times the square root of 3 over 2 minus the square root of 2 over 2 times 1/2. So this would be the square root of 6 over 4 minus the square root of 2 over 4, which of course is just the square root of 6 minus the square root of 2 all over 4.
Okay, well, there are other numbers you could use to do it, right? Like, there's different ways, right? Like, if I were to use the other, like,
What do you mean?
that would work too, but,
What do you mean?
like, okay, so I sort of forgot we did number to the top, right? 120 minus 45, so I used the other formula. Is that
Okay, yeah, no, that's fine. Yeah, absolutely. Well, wait, 120 minus 45, that would only be,
no, I did it on top.
okay, yeah, no, you're right. Yeah,
I
yeah.
did it double. I did it double.
120 and 25, yep, that's fine. And you should get the same thing.
Yeah, I did.
Yeah. All right, so now this one's a little bit trickier. All right. Because you're not used to dealing with radians quite so much. The funny thing is, when I was, taking trig, I hated radians. I'm like, God, why would you ever use radians? Like now that I teach it and I teach radians and I see radians all the time, I'm like, why would you ever use degrees? Like radians are just, to me they're a lot easier and they make a lot more sense. But to most students, they don't because you haven't seen them enough to get to that point, right? But yeah, if you really super get stuck, right, just remember, oh, okay, well, let's multiply this by 180 over pi, right? And we say, oh, okay, well, that's going to be 15. Oh, okay, well, that's just the same as 15 degrees, right? Which is really the same as 45 minus 30, right? There's, again, right, as was just brought up, there's tons of different ways. I always try to do it using the smallest angles possible, right? But sure, if you wanted to do like 135 minus 120, sure, you're going to get the same thing, right? It's not going to matter. So this is essentially the cosine of pi over 4 minus pi over 6. Right? And of course, if we think about common denominators here, this would be 3 pi over 12 minus 2 pi over 12, which would give us 1 pi over 12. Right? So this is our cosine of u minus v. All right, so this is cosine u cosine v plus, because with cosine it's the opposite sign, right? Sine u sine v. Sure. Sure. Well, let's just do it in terms of straight pi, though, right? If I want to subtract these, I have to get a common denominator, correct? And it's going to be 12, right? So in order to make this 12, I have to multiply both of these by 3. And in order to make this 12, I multiply both of these by 2. So we end up getting 3 pi over 12 minus 2 pi over 12, which then, of course, is just pi over 12. Not a problem. All right, so here we're going to say, all right, well, cosine of pi over 4 is square root of 2 over 2. And cosine of pi over 6 is square root of 3 over 2. Sine of pi over 4 is square root of 2 over 2. And sine of pi over 6 is 1/2. I'll just go ahead and combine these into one, since they're going to have common denominators anyway. This is going to be the square root of 6 plus the square root of 2 all over 4. Yeah, that's fine. Yeah, going from here to here is perfectly plausible. Like if it's a step that is in my opinion, very easily done in your head, it's okay, right? But some students try to, I'm like, there is no way on God's green earth you went from that step to that step. You know what I mean? Like, obviously you cheated somehow, right? So, if it's something that's that obvious, then, I'm perfectly fine with it. Go ahead and try this one, of course. Okay, so of course we can break this up the same way that we broke up the last one, right? Since it's pi over 12, just like our last one was pi over 12. So of course this is sine of pi over 4 minus pi over 6. All right, so here we know that this is sine of u minus v. All right, so that is sine u cosine v minus cosine u sine v. So of course we pull all of these from our unit circle. So square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So of course we get the square root of 6 minus the square root of 2 all over 4. Good times had by somebody somewhere? Not good times? You mean you don't love the sum and difference formulas for trigonometric functions?
So for whenever it's
Not really.
when it's sine of u minus v,
Uh-huh.
it's minus and not plus.
Right. Sine is the sign that like is there. Cosine is the one that's opposite. Okay. So here, all right, find the exact value of the expression. All right. Let's go. Let's change this up to make it nicer. Let's make this 70. Right. All right. So basically, this is going backwards, right? So if we call this u and this v, then this would be u and this would be v. All right. So sine u cosine v plus cosine u sine v. All right. This is equal to sine of u plus v, which in our specific instance is sine of 110 plus 70. All right, so this is equal to sine of 180 degrees. Sine of 180 degrees is just 0. Yeah, that's just working backwards, right? Like we're starting with the expanded formula and we're condensing it going the other direction. The only one that's more difficult is tangent, and it's not because you do anything different, it's just because the formula is a little bit more complex. But you'll still have that formula in front of you, you know what I mean? Like,
So we could just do that for both sides.
what do you mean?
Are we done?
We're done. That's it.
Oh, you just did.
Mm-hmm. That's it.
Okay, I got it. Because we're using like a formula, it's almost like
We're going backwards. Exactly. 100%. 100%. What's that? Well, not without a calculator, right? Like you wouldn't be able to get 110. I can't think of a way where you would have been able to get 110. You know what I mean? Or 70 for that matter, you know. But if you could, theoretically, yeah. Okay. You actually could have used the co-function identities there, but it would have been a little more work. Okay. So here we have cosine u cosine v minus sine u sine v. So which formula is that? Yes. So this is cosine of u plus v, which for our purposes is the cosine of pi over 16 plus 3 pi over 16, which is just 4 pi over 16, which reduces to pi over 4. Agreed? And cosine of pi over 4 from our unit circle is simply square root of 2 over 2. And we're done. Well, no, because it actually, all of this whole thing is just equal to this right here. That's it. So this all condenses down into this. Does that make sense? Yes.
Like, you were a cheerleader.
Okay. So now this one's going to be a little bit interesting. All right. So of course this is our tan u minus tan v over 1 plus tan u times tan v. All right. So this is equal to tangent of u minus v, which of course in this case is tangent of 154 minus 49. All right, so this is equal to the tangent of 105, yes? Okay, now, is 105 on our unit circle? No. All right, but can we create 105 from angles on our unit circle? I think we can. I think the easiest way is probably 60 plus 45. Yes, no, maybe so? All right, so basically we had to work backwards and then work forwards again. All right, so now this is my new u and this is my new v. All right, so tangent of u plus v is equal to tangent of u plus tangent of v all over 1 minus tangent of u times tangent of v. Note the whole formula for tangent of u minus v is tangent of u minus v is equal to tangent of u minus tangent of v all over 1 plus tangent of u times tangent of v. Like, that's what the whole formula states. It's the exact opposite of this one, right? Like, if this is a minus, then this is a minus, and this is a plus, which is what we have here. Okay? All right, so now, of course, my u and my v, my new u and v, are 60 and 45. All right, so here we are really going to have tan 60 plus tan 45 over 1 minus tan 60 times tan 45. All right, so tangent of 60 is the square root of 3. Tangent of 45 is 1. So 1 minus the square root of 3 times 1, which, of course, the times 1 doesn't really do anything, right? We don't really have to put it there. We aren't allowed to have square roots in the denominator, right? So what am I going to have to do? If I multiply it by just the square root of 3, then I'm going to have to distribute it, and I'm still going to end up with a square root of 3 down here. All right. It's actually not 1 minus the square root of 3. It's 1 plus the square root of 3. That's actually called a conjugate. We use conjugates a lot in math, so you use them in algebra 2 a lot, except they were called the complex conjugate. Right? If you had a plus bi, you used a minus bi. Same concept. All right, so I'm going to multiply top and bottom by the conjugate, which is the same thing. I just changed that middle sign. So now when I distribute up here, I'm going to get the square root of 3 plus the square root of 9, which is just 3, right, plus 1 plus the square root of 3. That I just FOILed. All right, down below, I'm going to get 1 plus the square root of 3 minus the square root of 3 minus the square root of 9. All right, so of course, the plus square root of 3 minus square root of 3 will cancel here. All right. Of course, the square root of 9 is just 3. Same thing down here. All right, so here we have 3 plus 1 is 4. The square root of 3 plus the square root of 3 is 2 square roots of 3. And down below, 1 minus 3 is negative 2.
Why do we get 4 whenever we take out the 9? The first 9.
The square root of 9 is just 3.
Right, but don't we take those out?
Take what out?
Well,
I mean, does it make sense though? Just this is essentially right here is just 3 plus 1, which is why I got the 4.
I thought you were crossing them out to cancel that.
Oh, no, well, no. Right. Okay, so now, because both pieces up top are divisible by 2, right, I'm going to go ahead and do that. In fact, I'm just going to go ahead and divide them both by negative 2. So 4 divided by negative 2 is negative 2. And 2 square roots of 3 divided by negative 2 is just negative the square root of 3. And that's my final answer. So that's by far I'll say the most difficult one. It's not that anything we did there was difficult. It's just that there's a lot of it. Is everybody okay with how I simplified there, or do we need more detail? Think we're good? I mean, I don't mind explaining if I need to. Is everybody okay with the simplification? Yeah? Okay. This looks hard. It's not. Okay. So given sine of u is equal to 4/5 and that u is between 0 and pi over 2, and that cosine of v is equal to negative 12/13 and that v is between pi over 2 and pi, find the following. Okay. So what we're going to do here is we're going to make triangles. All right. So here it tells us that I'm between 0 and pi over 2. Which quadrant does that mean I have to be in? The first quadrant. All right. So I'm definitely in the first quadrant, and this is my angle u. All right. Sine of u is 4 over 5. Of course, sine is opposite. Thank you, sir. Over adjacent. Over hypotenuse. All right. So then you can either use the Pythagorean theorem or use just your knowledge of Pythagorean triples and know that this is a 3, 4, 5 Pythagorean triple. Of course, a squared plus b squared equals c squared would have gotten you to the same place. All right. So now that allows us to find any pieces that we might need, right? We know sine of u. Well, now I know cosine of u is going to be adjacent over hypotenuse, so 3/5. And tangent of u is going to be opposite over adjacent, so 4/3. All right, we can do the same thing with v. SOHCAHTOA, right? Yep. All right, so here with v, it tells us that we're between pi over 2 and pi. What quadrant am I in there? The second quadrant, exactly. All right, so I make angle V in the second quadrant. All right, cosine is adjacent over hypotenuse. Of course, from here I'm going left, so my 12 has to be negative. Again, you could do a squared plus b squared equals c squared, or know that this is a 5, 12, 13 Pythagorean triple. All right, so, and then we can do the same thing here. We already have cosine, so we need sine of v. Sine, of course, is opposite over hypotenuse, so 5/13. And tangent of v is opposite over adjacent, so negative 5/12. All the hard stuff is done. Now it's just plugging it into the formulas that you're going to be given, right? Well, we know that sine of u plus v is sine u cosine v, right? So sine u is 4/5 times cosine v is negative 12/13 plus cosine u, we just found, is 3/5 times sine v, we just found, is 5/13. Now, this would be on the calculator portion of the test, so you'd be allowed to just plug this into your calculator exactly as you see it. All right, now this is going to be negative 48 plus 15, so that's going to be negative 33 over 65. Of course, you could just do that with the calculator. You wouldn't have to do that in your head. All right, same thing down here, right? We just use the cosine u plus v formula that we wrote down previously and plug in all of the stuff, right? So cosine u is 3/5 times cosine v is negative 12/13. All right, minus sine u is 4/5 times sine v is 5/13. All right, so here we have negative 36 minus 20, so negative 56 over 65. Of course, tangent is the one that's a little bit more complicated formula-wise, but still not bad. So tangent of u minus v is equal to tangent of u minus tangent of v over 1 plus tangent of u times tangent of v. Again, you can just plug this into your calculator, right? And honestly, that's probably the far easier method to use here. What in the heck just happened there? Okay. So, whoa, what is going on here? This thing just freeze on me? Son of a biscuit. Rainey, that's your fault. Exactly. Well, right. It's got to be somebody's fault. Okay. So, here, all right, now you'll want to do a lot of, we'll want to do a lot of alpha y equals here, all right, because this can get kind of messy looking. All right, so we're going to have 4/3 minus, whoops, let's not do that. No. let's go negative 5/12. Yeah, you could. All right, and then 1 plus 4/3 times negative 5/12. All right, so 63/16. That's it. Done. All right, so I mean, really, guys, having the formulas in front of you, this stuff's pretty straightforward, right? I mean, it's not anything crazy. It's not anything overly, complicated. Yeah, just